project. It's a Python text adventure, so kind of like Zork, but I'm trying to write it in Python. So to start off, we have my thing class. So things I define as just anything, I guess. I didn't call it object because that obviously has some problems with the name. So things can be props or actors, or I guess in theory I could also have rooms implemented as things, even though I have a separate room class. I might change that in the future. But yeah, so things have some cool properties. Things have a name, a description, and a short description, all of which are used to describe them when you quote unquote look around a room, right? They have, actually, I've changed this back, so ignore that. Things have this special property where, because of the way that I use them, I load things from JSON, but I give them, I have the ability to arbitrarily assign traits and attributes. So, wait a second, this is the wrong thing. Content, I want props, rock.json. Okay, so I make rock.json, and instead of worrying about making a rock class that inherits from thing, instead I just make rock.json. It has a list of traits, it has a name, description, short description, and then it has whatever I want here. So in theory, this rock is technically also a gun, although I haven't implemented this. But I could implement a can shoot trait, which I will show you in a second. So has all of these, is weapon, and has HP. Now, when you initialize a thing, you initialize it from a JSON file. It goes into it, loads it, and then sets all the attributes in the JSON file to attributes of the object. Some other custom behavior. There are two built-in methods for getting attributes from objects. There's double underscore get attribute, and there's double underscore get attr. Get attr is the last ditch effort call to find an attribute if get attribute doesn't find it. So in this case, if you try to, I define actions that you can do on objects as just class methods, so, or instance methods, I guess. So if you try to call a function, for instance, sword.eat, then it will return a lambda, which gives you back a string that says, I don't know how to eat the sword. Although I could override that with custom behavior to do something like, I don't think that's advisable. Also, all my functions that do things in game return strings. So the reason for that is because in a text-based game, everything that you do has to be described, whether it's a success or a failure or just something that's not recognized. So if I return a string, then I can always print the output of a function. So then down here, we just have an add trait method, then add traits, which is pretty self-explanatory, and then some default things. By default, you can't harm something if it can't be harmed, and by default, you should be able to look at something. So it just returns its description, right? And then down here, these are more things which manipulate class methods. So like has attribute, get class. Let's see, assert instance attributes is important. It ensures that, for instance, something like is weapon, the implementation that I have a list of things that are required, which includes damage, so how much damage it does, and has HP requires HP and max HP. So I will show you now the traits. So traits are just classes that have no init function. Instead, they just have a name such as has HP. They have a required attributes thing, which is just built in and static. So for instance, has HP, like I mentioned, has HP and max HP. And this will raise a runtime error when you start it up if an object that you're trying to assert has HP doesn't have HP, right? So things that have HP can be harmed. You see there's an amount of damage. Then it does the logic there and it tells you the status. And the status is like for inanimate objects is pristine, battered, damaged, or destroyed based on how much health out of its max health it has. And then look tells you the status as well. Is living is similar to has HP. In fact, it actually kind of inherits from has HP. And it has its own custom status thing where instead of pristine or damaged, it has healthy, battered, bloodied, and dead, which makes sense. Is edible, same deal. Has inventory, same deal. So this allows me to arbitrarily implement behaviors. So if I want to, I can have full creative freedom to just go through, make a bunch of JSON objects. If I don't have a trait, but I want to have a behavior, I can just add a thing that's like is key to door, and then have it have like a door ID that it opens or whatever. And then later I can just go in and implement that, but this just opens me up creatively. All right, so that's the object implementation. Let's see, rooms, as I said, I think I'm just going to have rooms be objects rather than their own separate things. One notable thing is that rooms have a map of doors. So the key is the direction, and then actually this is incorrect. Instead of cave 2, this should be like door 1 or door 2 or whatever. And then somewhere else I should define the doors and have the doors link things. You see the way the map's laid out, it's supposed to be like a graph of nodes linked with directed edges. So doors are their own separate thing that oh goodness, I forgot to implement doors. That's okay. So next up, registries. A registry is basically just a wrapper class around a dictionary that has a certain type that it can contain. So the purpose behind this is that when I tell the dungeon master, which is the component that kind of manages all the state of the game, when I tell the dungeon master about a new thing that I've created, like a new object or a new room or whatever, I will register it in the respective dictionary. So for instance, there's a door dictionary, which is just tracking all the edges of the graph. There's a room dictionary. And this is nice because it means that I can have an ID for everything and an easy way to retrieve objects. So yeah, then you can register, deregister, git. And then down here, this is just stuff to let me index things normally. Oh, this is a duplicate. But yeah, then I have room, which is basically just a less fleshed out version of thing. So not much to say there. And lastly, the last thing I've implemented, at least partially, is Dungeon Master. So Dungeon Master, oh wait, actually, I have parsing as well. So parsing just parses stuff. So it takes a string. The structure of a command is either verb, direct object, indirect or instrumental object, or verb, direct object. So this is like hit troll with sword. This is eat bread, and this could be like look or inventory or something. So first thing it does is it strips away articles. Well, it lower cases the text just so that there's no casing problems. Then it removes all the fluff, like the articles. Then it splits off the first word because we know that's the verb. And then it parses the rest, separating it with, or by the with keyword. I might add more synonyms for that, like using maybe. But then it just returns a tuple containing the verb, the direct object, and the indirect object. And so in the Dungeon Master, this is where all the magic happens. You initialize it. Later I'm going to use glob to just open up the content directory and load all of that into memory. The config.json will have stuff like a start room and I don't know, maybe a difficulty or something. But yeah, then run command. Right here, I'm using a match statement. to parse whether it's a single verb, a verb with direct object, or a verb with direct object and indirect object. Then down here I have the actual game loop. So the idea here is that the command is gotten by prompting the user and then stripping it of any white space. And then it runs the command. Let's see, when we run the command. Oh, right. When we run the command, we parse the command with simple parse. And run commands then should run any logical functions that it needs to on the object. Yet to implement is an item is present and a find thing. So item is present. Wait a second. These are the same thing. Whoops. Anyway, I just need a function that, for instance, if a player wants to take a sword, then they can't do that if the sword isn't in the room. So you need to check the room. Or if a player wants to eat bread, they could eat bread that's in the room, or they could eat bread that's in their inventory. So they'd have to check the various places that it could be. And then maybe also check open containers in the room. Like if there's an open box that contains a bunch of bread, you should be able to eat that. But yeah, and then do action is a function that's eventually going to just call whatever function on a thing that it's given. But yeah, so far, that's my entire code. Kind of ran out of time before I could fully implement everything, but I'm still chugging along. So yeah, good stuff.